Hi guys, good to see you all. I see that we've already got a fair few people tuned in, which is great. I waited a little bit today until a few people had joined and managed to post a link to a couple of places. So hopefully we'll get a few more people joining us shortly. Um, anyway, I'm going to start by talking about the rough plan for today. We're going to start off with a bit of a health and well-being message. I came across this thing on this interwebs of ours that kind of made me think a little bit more about how we can put things in perspective. So I'm going to open with that today. We're then going to talk a little bit about a couple of admin things that we need to get right, just when we're working on teams and that sort of thing. From there, we're going to go on to maths, where we'll just cover a little bit about percentage increase and decrease, because I know that's presented one or two problems for a couple of people. A few people have messaged me about that. So that's great. We can go over that. Gives me a chance to actually be a teacher, which, that's the whole point of me being here. And then lastly, to finish off the lesson today, we're going to be looking a little bit about electricity. I've tried to bring some stuff with me. I got batteries, I got light bulbs. I'm going to see if I can teach a relatively interactive electricity lesson, which is kind of hard when I can't have you guys experimenting alongside me. Please don't try to experiment alongside me. Don't go trying to pull your plugs out or strip the wiring in your house. Big mistake. But I'll try and do a little sort of experiment here. Talk to you a little bit about the history of electricity, and you can hopefully learn a couple of things along the way. So how many are we up to at the moment? 28 people so far, up to 30 now. That's good. So I'm just going to get started now. And I'm going to start with this health and well-being message that I came across. Now, in some ways, this may be more pertinent, more relevant to your parents in some cases. This was something that I saw, and I sort of thought, as a parent, I might quite like to hear that in a way. So this is meant to be a conversation happening 10 years from now, in 2030. It's between a kid at the end of their high school career and their parent. And the high school kid is saying, in history class today, we learned about that whole COVID-19 pandemic all the way back in 2020. I didn't know it was that bad. What was it like living back then? The parent responds, well, everything was shut down in an attempt to kill the virus, but there was a problem because not everyone followed the quarantine rule, that you had to stay inside for 14 days. There were sadly a lot of deaths that shouldn't have happened. Grocery stores were running out because everyone was panic buying and hoarding as much as they could. We were scared for all sorts of things, our economic future. But wait a minute, why am I telling you this? You remember, you were like 8, 9, weren't you? I know you guys are 10, but just in this example, it was an 8-year-old. So how come you don't remember? You were 8. And this kid responds by saying, all I really remember about it was that the schools closed and we had to be homeschooled. I remember doing scavenger hunts in our garden. I remember eating meals as a family for a change. I remember getting a great sleep because I wasn't up late doing homework or getting up early for school every day. I remember board games as a family. I remember watching our teacher on our laptop. I remember having just really good family time. Honestly, it was one of the happiest times of my childhood. And reading that, I sort of thought, you know what, that's actually quite a nice message, because there's all this stuff going on that maybe makes us feel a little bit negative, a little bit apprehensive, a little bit anxious. But then again, for you guys as kids, I suppose there's a lot of other ways of looking at this whole situation. I thought that was just a nice message to kind of open on. It might be something that might be nice to share with your parents. So yeah, just something to kind of meditate on a wee bit. So what I want you to do just for a minute or two is to try and let's try and post something, not so much that we're thankful for, but something that we are just feeling really positive about at the moment. Maybe like try to take the situation at the moment and think, well, actually, what's good about it? Are you managing to play board games as a family more? Are you managing to spend a little bit more time around the family dinner table talking about stuff? So get typing on your keyboards just now. What is it for you that is kind of a positive thing for you, for you at the moment, something that's making you feel, you know what, actually, this situation has its upsides at the moment. We've got Freddie here saying, being with my family, being with your family. I think that's a really nice thing. So that's a really good positive message there. Happy because the Great British Menu is still on TV. That's good. That's always a silver lining. I've actually managed to escape watching that recently. My wife normally really enjoys it, but we've managed to avoid it this year for a change. Ellie saying a bit more time with her family as well. Jessica saying a bit more time with her mum and dad, playing darts, having more laughs, enjoying more movies together. We've got, I think that's Callie saying, eating food with your family, talking to each other, having that you can still learn. I think that's really good as well. So actually, despite the potential negativity, the pessimism that we're sometimes prone to feeling, hopefully we can learn to be a little bit more optimistic and realize that actually every situation has its upsides, and that we can look for the positive, look for a bit of optimism, even in some slightly more negative situations. Okay, so that's our wee health and well-being brief today. From here, I'm just going to quickly talk about a couple of admin things, because we've got how many people in the chat at the moment? Nearly 40 of us, so this is a good message to get out. So first thing is, please don't get stressed over work. We want you guys to do what you can, but if it's ever, at any point, resulting in hurt feelings or tears, then just stop. Just stop. That is not the point of education. I need you guys to love learning. You can see I love learning. It's something that I'm really passionate about. And if at any point it's making you despair, it's making you just feel negative about things, stop, take a break, maybe come back to it later if you have time. But we get it if you're not getting through everything that we post. Some people are saying that we're posting too much. That's kind of based on a bit of a misunderstanding of what we're about here. We're not necessarily expecting all of it to get done. Great if it is. It's really great if it is. We love it if you manage to get all the work done. But don't freak out if it's not. Okay, who's checking anyway? We're trying to respond to what we can online when you post it. But realistically, we're kind of limited by how much we can check up on you guys. So don't go panicking about not getting through all the work. And if you're finding it too hard, that's where we've got things like the live stream, where hopefully I can go through a couple of examples on the board and help you understand it a bit more. Another quick admin point, second admin point here is, please, if you can, in fact, not if you can, just please stop posting your work to the files section on Microsoft Teams. Post it to the chat feed, because that way everyone can see it. You can all see each other's work. You can feed back on each other's work, and it's a far better way of going through it. If you post to the files section, it just fills up the files feed, and it makes the work that we're posting there much harder to get to. And please be very careful when you're looking for work on the files feed, not to accidentally edit the files in any way. Don't change the files. If it's a file that has been created by Miss Lindsay or myself, we've created it that way for a reason. Leave it as is. The final thing then, before we move on to math, sorry, I know I'm doing a lot of waffling here, but the final thing is, for my class in particular, I know you guys are used to having had the class curiosity tree. I'd like to kind of keep that going here. So in the general chat, what I'd like, so not on the live feed today, but on Microsoft Teams, what I'd like you to start doing is, if you have a sort of class curiosity tree item, then you can ask it by typing hashtag, I'll try and put on the post here, hashtag CCT followed by your question. Oh, why don't we make a new channel? That's actually, you know what, that's not a bad idea, Miss Lindsay, rather than filling up the general chat. So we will instead create a new channel for the class curiosity tree. And if you have any particular questions on there, you can post your questions to the class curiosity tree channel on Microsoft Teams. Because I think it's quite a nice thing to be able to go over, and then I could try and I won't be able to answer everything, but I'll try and answer a few of them on these live feeds. Okay. Right. Okay. So from here, we'll go over a little bit about percentage increase and decrease, because I know a few people, most of you were doing absolutely great with this and fantastic, because it's a much trickier skill. If you weren't getting it, don't worry. But we'll go over a little bit of this just now. So when it comes to percentage increase or decrease, we do need to work out the percentage, but then we need to add it to the original number. So let me make sure that I get my my board in shot here, so you can hopefully see what I'm doing. There, right. Okay. So to start off with, let's try, and you can join in along with me here. To start off with, we're going to reduce. So we're going to take 30% off of 80. So notice I've used the word off with two F's there, not one F. So there's not 30% of 80, it's 30% off 80. We are going to reduce 80 by 30%. So to do this, what we're going to do is we're first of all going to work out what 30% of 80 is. So the way I would do that is I'd start off by working 10% of 80. Horrible handwriting here, I apologize. 10% of 80, well, we all know that that is, hopefully in the comments, 8. Therefore, 30% of 80, well, that's going to be 8 times 3. 3 lots of 10%, hopefully we follow that, which is going to be 24. So 30% of 80 is 24. However, what we're doing is we're trying to reduce 80 by 30%. So that means that what we need to do is we need to go back to our 80 and we need to take off that 24. We need to reduce it by 24. So what I'm going to do now is I'm going to do one final sum. And this is the part that some of us were forgetting to do. So a lot of us saying 24 is the answer, 24 is the answer. No, 30% of 80 is 24. But if we're reducing 80 by 24, what are we going to get? So 80 subtract 24, being careful to line up my columns. 0 take away 4, say it with me, we can't do it. So we need to exchange. 10 take away 4 is 6, 7 take away 2 is 5. So our answer then should be 56. And I'm seeing that answer popping up a lot in the comments. Excellent, well done if you managed to do that. Let's try another quick example. So that was reducing. So I could have, I wrote that as 30% off with 2 F's. I could have also wrote reduce 80 by 30% or something like that. You might see that question a couple of different ways. This time we're going to do the opposite. We're going to do a percentage increase. So we're going to add an amount to it. So let's do, I want you to increase. I'll tell you what, I'll do 2 versions. So we'll do a sort of milder version and then a hotter version. So increase, we'll make it 60, and I want you to do it by 40%. That's the slightly easier one. And then a slightly harder one, along the same lines, it's just going to involve an extra step, is increase 60 by 45%. So 2 of them for you to try there. Okay, got some. If you got to go, you got to go, pal. Don't worry about it. Just noticing someone in the chat there saying that they're off. That's fine. But those of you that are still here, let's try this one to start with. So we're looking to increase 60 by 40%. Well, what we're going to work out first of all, right enough, we're going to work out 10%. Okay, so 10% of 60, well, that's going to be 6. Therefore, 40% of 60, hopefully you can see this on the screen, is going to be 6 times 4, which is, once again, going to be 24. Okay, so 40% of 60 is 24. Now, if we're increasing it, I'm seeing the answer popping up already, which is excellent. If we're increasing it, then we're going to add that 24 to our 60. So it's going to be 60 plus 24, and that's going to give us 84. Now, In the case of the next one, it's pretty much the same, and we've already worked out the 40%, but you're also having to add a 5%. Okay, it's not how. Cammy, try and stick to the topic, pal. We're in the middle of maths. We ain't talking about sheep right now. Okay, as much as that'll get a laugh from like 2 people, let's stay on topic, please. Right. So increase it by 60%, 60 by 45%. Well, we're going to work out our 10% once again, which was 6. We're going to work out our 40%, which was 24. But then the bit that has tripped some people up in the past is working out that 5%. So how do we turn 10% into 5%? Well, we half it. Okay. So if 10% was 6, 5% is 3. That means then that 45%, well, I'm about to go off the screen there, 45% is going to be 24 plus 3, which is 27. Oh, I'm only just in the shot there. There we go. So the final step then, if 45% is 27, and we need to increase 60 by that, well, we're going to do 60 plus our 27, which was 45%, and we get the answer, which I've seen on the chat plenty already, 87. Well done. Hopefully that makes sense to everyone. I know a couple of us had issues with it. Hopefully that's cleared it up for us a wee bit. So if you're increasing it, you find the percentage and you add it back on to the original number. If you're decreasing it, you find the percentage and you take it off the number. You subtract it, from the number. Okay, guys, right. So that's our maths catch up. How far into this lesson are we? Only 15 minutes. That's fine. So this will probably be a bit of a shorter lesson today, but we're going to now talk a little bit about electricity. And I'm going to kind of do it through the medium of story. So I'm going to tell you a wee bit of a story to start with. And then I'm going to try and do 1 or 2 practical things. I'll see whether it works. I don't know if you'll be able to follow along. Frankly, I don't even know if you'll be able to see the desk that I'm doing it on. I will try and angle the camera appropriately. I might be having to like look up at you at a weird angle and stuff. But we'll see if it works, okay? Let's give me a bit of space. Excellent, right. So I'm going to tell you about 2 famous scientists today, both of which made monumental discoveries about electricity way back in the day. Now, once upon a time, there was a man called Luigi Galvani. And he was working with 2 different types of metal. I believe it was copper and zinc, and he was playing around with copper and zinc. And if you've ever played around with copper and zinc, if you, for instance, don't do this, big hygiene issues. But for instance, if you get a copper coin and let's say a screw or a nail that's been plated in zinc, and if you put them both to your tongue, you'll notice you get a really weird taste, a really weird sensation going on, almost like a very mild electric shock. Nothing too intense, but you might have noticed that with some types of metals. If you touch them both to your tongue, you sort of go, oh wow, that's an odd sensation. Mr. Luigi Galvani took this a step further. What he decided to do was to get a couple of frog's legs, dead frog, and he tried taking a piece. Have I done it? Yes, I have done that as a kid, Nathaniel. Yeah, I don't recommend you do it though. Okay, certainly if you're talking about a copper coin, it's not a good idea to go putting that in your mouth. You don't know where it's been. Anyway, if you take what Galvani did was take 2 of these metals, a piece of zinc and a piece of copper, and he noticed that when he touched it to a dead frog, touched it to its legs, the legs started to twitch all of a sudden, which is a bizarre thing to have noticed, a really bizarre thing to have happened. Poor frog. Do you eat meat, pal? Poor frog. These things happen. It was a dead frog. It's fine. It wasn't alive. It wasn't feeling anything. The frog's legs started twitching, which is quite an interesting thing to have noticed. What he had accidentally discovered is that electricity can be generated if you have two different metals with different amounts of free electrons. So remember last time, let's get our friendly classroom board back in the mix here. Last week we talked a little bit about atoms and how some things conduct electricity when others don't. 10 points for the first person who's able to tell me, why do some metals conduct electricity? Type furiously on your keyboard. I'm going to try drawing up an atom just now, but who gets there first? Why is it that some metals conduct electricity? I'm going to draw my wee atom here. So we've got a whole load of things in the middle. And, we might have one or two things on the outside. That would be 1, 2, 3, 4, 5, 6. We should have 6 electrons as well there. Hey, Miss Ferguson got there first. Rosalind, well done. So, because they have free electrons. So most atoms have their protons in the middle and the electrons whizzing around the outside, but the electrons are stuck inside certain clouds. So if this was the cloud here, and I'm not doing a proper sciencey diagram here, but if this was the electron cloud, the electrons would be stuck inside that electron cloud. However, metals have electrons that aren't always stuck to the cloud. They have electrons that can float around the outside. So if these electrons are all in the cloud, this one is outside of the cloud and it can kind of do its own thing. Which means that if something pushes this electron forward to the next atom, so this one jumps over here now, then the electron that it had is going to be passed on as well. And so we get something being passed on. Okay? So that is how some things conduct electricity. And in the case of Galvani, what he'd noticed is that zinc was able to pass, or maybe, I can't remember which way around it is. It's either zinc passes its electrons to copper, or copper passes its electrons to zinc. Either way, when it went through the frog's legs, it gave the frog a mild electrical shock, causing it to twitch. Okay, so that was, at the time, a fairly monumental discovery. However, on its own, it didn't do much. However, along came this other guy. So we've already had Luigi Galvani. We've now got Mario. No, it's not Mario. Just thought I'd try and get Cami and Nathaniel excited there. Not Mario, but Alessandro Volta. Alessandro Volta. And what Volta discovered, you might recognize the word Volta. He basically discovered the battery. He created the first battery. And the way he did this was by taking, if you like, standing on the shoulders of the giants that came before him, like Galvani. He heard about Galvani's work, about zinc and copper, and he thought, well, what if we layered them up, one on top of the other? So what if we had a plate of zinc followed by a plate of copper on top of each other, and did one after the other? So we did copper, then zinc, then copper, then zinc, and then copper, and then zinc. And what he created was a stack of metal plates, one on top of the other, copper and then zinc, copper, zinc, copper, zinc. And when he ran wires from each side of it, between the wires, he would get an electrical charge. He had created the first battery. So Volta was the guy who created the first battery. Now, since then, we found lots of other ways of creating batteries. We have batteries like our, I can't actually get this one out, which is a bit annoying, but we've got batteries like our humble AA battery, which you can't get out because I've wedged it in here fairly firmly, but your standard AA. We've got our 9-volt batteries, and they work in a different way to this, but it's using the same principle. It's using the idea of basically pushing electrons. All batteries do, all batteries are for, is pushing electrons around. So they generate a force. Okay, now that is what we're going to kind of look at in this lesson here. So I'm hopeful that if I tilt the screen, yeah, you can just see my desk there, so that's fine. So what we're going to look at is how batteries kind of work, and we're going to look at two different types of circuit. Now, you've hopefully done a little bit of work on this already. I think we talked a bit about series circuits versus parallel circuits. So what I'm going to set up just now is a very simple, well, I'll set up a very simple circuit first of all. So here's a battery, little 9-volt battery, bit too much voltage for these light bulbs, but it does make them shine very bright. It might cause them to burn out as well. So if we get that happening, I'll need to change it. Now, let's say I connect up my wire to one side here. Now, in theory, surely some electricity could come out through this wire just now, and I'd be able to feel that. Well, actually, no, I can't really. And if I connect it to this bulb here, nothing happens. I mean, the bulb is connected to the battery, but nothing's happening. Why is that? Hopefully, we kind of remember, we maybe talked about a river analogy. Electrons are flowing out of here and around here, but they need to be able to get right back to the start again to complete what's called a circuit. So in order to get this to work, if I connect up this side of the light bulb, and then also connect up this side of the light bulb and bring it back, oh, we're tipping all over the place here, bring it back to the battery. As soon as I make contact here, hopefully we'll see it light up. And there we go. So by creating a circuit, we have electrons flowing out one side of the battery and back to the other side of the battery, like so. Okay, what happens if we connect up more than one light bulb here? Well, let's try that. I'm a bit pushed for space, but we'll try another light bulb here. And we'll try another light bulb here. Now, I'm doing this with quite a powerful battery, like I said, so actually we might not notice too much of a difference. And because it's all a bit coiled up, it's hard for you to follow the route. Think of this like a wee puzzle. You have to kind of follow the route around here to figure out what's going on. But there's 3 light bulbs so far. And you know what? Let's just try it back to the battery just now. So in order, we've got, if the electricity is coming out of this end, we've got it coming to this one, and then this one, and then this one. Now, I want you to make a prediction. At the very least, make it in your head. If you can't make it in your head, then sorry, if you can, type it out. But if you've not got time to make it, type it out, then just make it in your head. What do you think is going to happen? Are they all going to light up? Is only one of them going to light up? Which one will light up? Will one be brighter than the others? Make your predictions now. What do you think is going to happen? Let's have a wee look. Oh, actually, in this case, nothing, which makes me think, oh, here we go. Right, now, this is quite interesting. Okay, we have this bulb on this side being the brightest. Oh, I think we've got a loose wire somewhere. That's why we're losing a bit of connection. But this one's much brighter. This one's a little bit duller, and then this one is by far the dullest. Okay, that's quite an interesting discovery. So let's follow the circuit here. We have this one here, which is the negative end. Okay, you can see it's got a minus sign beside it. And that one, so if we follow the wire, the yellow wire here, comes to this bulb first, which is shining the brightest. I think it's this wire that's the problem. I'm going to change out that wire. Let's try that. There we go. That's much more stable, I think. Oh, maybe not. There we go. Okay, so the green wire comes to this light bulb, then it's going around to this light bulb, and then it's going around to this light bulb, all a little bit convoluted, and then back to the battery. So what this tells us is that the electrons are obviously being pushed out of the negative side of the battery. So electrons, we call them negative. They are negatively charged. Therefore, they're going around to this battery, then that one, then that one. And actually, this one's so dim now that it's hardly being lit up at all. That's probably because we're running down this battery quite quickly. So I'm going to take it off just now. Okay. So what we should have seen there is that electricity flows out of the negative side of a battery, goes around and does work somewhere, and then comes back to the positive side. But here's a thought for you. How come when we turn on lights in our home, I've got a load of spotlights on the roof above me here, you can probably see, but they're all similarly bright. they're not connected up to a battery, they're connected up to the mains, but why do you think they're all similarly bright? What might the reason be for that? Because these 3 bulbs here, they were all different brightnesses. So any thoughts there? Hopefully you're ticking it over. Basically, I'll just give you I'll give you the answer because it's kind of hard for you guys to respond. But basically, the electrons are coming into the first one, and electrons are basically things that do work. And so they do a whole load of work at the first bulb that they get to. They create a whole load of light. By the time they go to the second bulb, they've already done work, so they're probably, they've kind of run out of some of their energy. So loads of energy at this one. By the time they get to the second bulb, they're lacking a bit of energy. And then by the time they get to the third bulb, they've hardly got any energy left. However, we can, I can't really set this up very comfortably just now, but what we can do, and I'll see if I can set it up actually, I'll try it in a bit, but I'll draw a diagram. If instead of connecting them in a series, so one after the other, if instead we all connect them back to the batteries, then they should all be equally bright. So what we saw just now, let me dry the board a wee bit. What we saw just now was if that's a battery, we saw there was a bulb here, there was a bulb here, and there was a bulb here. And so the electricity is going out, lighting up the first one lots, the second one a little bit, and the third one hardly any, and then going back. However, if I was to set it out a different way, we might get a different result. So what if I set it out something like this? Still 3 bulbs, but all of them are connected up in a different way. What we would actually get here is the same brightness on every bulb. It would run down the battery faster, run down the battery much faster. However, it should result in 3 bulbs burning with the same sort of brightness. So I'm going to try, it's a little bit hard with the materials that I have here, but let's try it quickly. Let's see if we can do this, and then that'll be the end of the lesson and we'll sign off from there. So a quick look here. We have our battery, and I'll tell you what, let's just run out 2 cables there. Actually, if I expose, well, let me get a wire that's a bit more exposed. There we go. I'd love to do the whole Blue Peter thing of here's one I made earlier, but it's not really how it works here. So let's do 1 wire running to a light bulb here. So that'll go to this light bulb in a minute. I'll not do it just now because otherwise we'll start running the battery down. We'll do another one coming to this light bulb here in a minute. There's so many wires, you probably can't see what's going on, but hopefully it will make the point if I can get it to work. Like I said, normally I would let you guys do this, but it's kind of hard for you to follow along without giving you all the equipment home with you for everyone. Right, okay, we got extra wires. Let's try and clear up everything we can. Right, so we have 2 wires coming out here. And when it gets to this point here, they fork off to 3 different light bulbs. And hopefully, or we will hopefully see that. And on this side, we've got the wire coming out. And this side, it forks off to 3 different wires. So all we need to do is connect up these wires to the respective light bulbs. So we have 1 there, and that's pretty bright. Let's try the second one. Hopefully it will be similarly as bright. We shouldn't notice any reduction in brightness if this is true. So we saw last time they were all different brightnesses. This time they shouldn't be. Okay, Oh, what do you know? I must have crossed the wire somewhere because somehow I've managed to make them go out of all things. So I'm wondering if I'm using too strong a battery or I've short-circuited it somehow. Well, that's embarrassing, but you know, live TV and all that sort of thing. I've managed to somehow blow the bulbs, probably because I'm using a 9-volt battery to do it. I'm not quite sure what's gone on there, but in theory, if we do a series circuit with them all connected in a line, we get brightest, less bright, really not bright. Whereas, again, in theory, hooray for science, thank you, Nathaniel. If you connect them in what's called a parallel circuit, which is the way things are supposed to be connected up in your house, then we should get them all working with a similar brightness. However, I've been unable to show you this today, it would seem, but hopefully you understand some of the principles behind it. Okay? Thank you. It would work in principle, Mr. Ramsey, but today it just didn't. We can't win all the time. Again, I think it's part of the materials I'm using. I'll maybe see if I can set it up and take a video of it some other time. Anyway, what we've learned today. We talked a little bit about health and well-being to start with. We did a little bit of maths. We talked about percentage increase and decrease and ways of doing that. So if you've missed that, go back and watch that. It'll certainly help you with your maths. We talked about two scientists, Galvani, who did two different metals, copper and zinc, on a frog's legs, and notice they jumped. And then we learned a little bit about Alessandro Volta, who created the first battery by layering up copper and zinc on top of each other. And then lastly, we tried two different types of circuit. One of them was a series circuit, which did work very well. The other was a parallel circuit, which should work better in theory, but today it didn't. Anyway, we can't win all the time. Hopefully you've still learned something along the way. If you've learned something, in the comments, think very quickly, what did you learn today? Because I've not been that interactive today. It's kind of just been me talking at the screen. To be honest, I've not been able to see the chat half the time. So what, guys, have we learned from today's lesson? So can you, not that science doesn't always work, try to think of a new thing that you have actually learned over the last while. Thank you, Megan's mum. I appreciate that comment there that's just come up. Nathaniel, the parallel circuit is a lie. Okay, I don't think that's very helpful. I like your portal comments, but they need to die down a bit now. Can we focus on the learning, please? Story about Luigi Galvani. Yep, so him and his frog's legs. Weird thing to be into, zapping frog's legs with 2 bits of metal, but that's fine. The Volt is named after Volta. Very good, Callie. Thank you. Aya and Amira, guys, can we please stay on the learning, please? Because the only point of me doing this, guys, the only point of me doing this is to benefit your learning. And if you're spending the whole time making meme references, it's not actually helping anyone's learning. It's just something for you to be distracted by. Okay? So can we stay on topic? Let them die just now. Consider this your classroom. Thank you. Learned about the frog thing, Nathaniel. That's cool. Okay, guys, so hopefully a few things you've learned along the way. The last thing I'm going to say then is hopefully we're going to create a couple of channels for you to, or not a couple of channels, one channel, an extra channel for you to post stuff for the class curiosity tree, and then that will form part of our lessons from here. Anyway, I'm going to sign off just now, guys. Take care of yourselves. I would say don't go outside and be good, but there's not much motivation to when the weather's like this. But take care, and I'll see you all next time, Monday, 10 a.m. Hopefully see you then. Bye, guys.